Hello again, and welcome back to our Introduction to Acids and Bases in Organic Chemistry. Hopefully you saw the first video already where we talked about the definitions and how they work in a reaction. Now we're going to talk a little bit more about conjugate bases and conjugate acids. So as we saw in the previous video, that was one type of problem that we can solve looking at the reaction. We can recognize the acid, the base, the conjugate base, and the conjugate acid. But another thing we can do is figure out what is the conjugate base given the acid. This is actually a little bit easier because we're just working with definitions. So let's look at these problems. For example 1, it says we want to draw the CB, that's conjugate base, for each of the following. That means that each of these things must be an acid, correct? So what we'll do is we'll take off the H+. So for the first one, we're going to look at HCl. We're going to take away one H+, and then we should have what's left over. So if we take away the H, then we'll have a Cl, and then because that had a plus, we're going to have a minus charge left over. So that would be the conjugate base for HCl. For the next one, we're going to do the same process, but it's going to be a little bit different because we're starting with a charge. So if you look at this one, it's HClO4 minus charge. So we're going to do the same thing. It's an acid because it is asking for the conjugate base, so we know that's going to happen. So we're going to take off one H+, and then we're going to see what happens. So if we do that, we'll have ClO4, and then we need to change the charge. Now we said whenever an acid loses a proton, it becomes more negative. So it's already negative, so we're going to have to make it one more negative. So basically it's going to be -2 charge instead of a -1 charge. And that's going to be the conjugate base of that acid. So hopefully that makes sense so far. Now let's see if we can draw a conjugate acid. Now remember, when we're drawing a conjugate acid, this has to be for something that is already a base. And ammonia is definitely a base. That's the first example. So we're going to do the opposite. Now what we're going to do for a base is we're going to add a proton. So I'm going to take NH3 and I'm going to say plus H+, which you don't have to write this out, right? But what it's going to make is going to be NH4. So I'm going to increase the number of hydrogens by 1, and then I'm going to have an overall charge. So my overall charge, since it started out as 0, is going to become more positive, so it should have a positive charge. And I know in this case that the nitrogen is going to be the atom that has the positive formal charge, which is why I wrote it on the left side and not on the right side. That sounds like a minor detail, but for organic, it's actually going to be very important where the formal charge is, so you will lose partial points if you put it on the wrong atom. So the conjugate acid for this one is NH4+. So for the next one on example 2, we're going to use the HClO4- just like we did in example 1, but this time we're going to draw the conjugate acid. So we're going to use the process that we used for the example we just did with the NH3. So the first thing we're going to do is add the H+, and now what is that going to give me? Pause the video and try and see if you can write the answer. Right, so hopefully you got something like this. So basically I just added the H to the formula and left everything else the same. And then what would be the overall charge of this molecule? Right, it's just going to be neutral, right? Because I've got a negative plus a positive equals 0. So that's our final answer. Now that we've sort of got the idea, let's try one more example with an organic molecule. So what we're mainly going to focus on in this class is drawing conjugate bases of organic acids. And really they don't always look like an acid, so we're going to have to do a little bit of a different trick for this. The process is the same, it just looks different. So what we're going to do is if we're drawing the conjugate base, that means we're going to lose an H+, right? Just like we did with example 1, so I left it there. But we have to figure out which hydrogen are we going to lose. We're going to learn some skills on how to tell which one's better to lose. So for right now, I'm just going to give you a few simple tricks. The first one is for example 3, all the hydrogens are equivalent, meaning if you take off one of the hydrogens, there's only one type of hydrogen that you have, and it would make the same thing no matter which one you take. So if I look at that, where are the hydrogens on example 3? Right, they're on the sides there, on the carbons on the side. The carbon in the middle doesn't have any hydrogens because it already has 4 bonds. Remember, that's the trick to using line bond / skeletal form. So if you know where the hydrogens are, you can find which ones come off. So I'm going to take one of those hydrogens off, so maybe I'll draw it off, it looks like that. And then if I take that away, what would be left over? Right, it's just going to be a CH2, but then I also have to consider the charge. So what charge should be left over if I take away an H+? Right, it's going to be a negative, so let's put a negative on here. And remember that carbon with a negative charge has a lone pair. So basically there's a lone pair there that you don't have to draw. I'm just telling you so that you know for future. So obviously this is not in perfect line bond form, so let's go ahead and convert it. That's our last step. So if we do that, it would look like this with a negative charge. And you're just expected to know that carbon with a negative would look like the structure on the left. It would have a carbon with 3 bonds and a lone pair. So hopefully that makes sense. For the next one, let's look at that, example 4. As you can see on this one, there's several types of hydrogen. There's hydrogen on the carbons, but also a hydrogen on an oxygen here. So we need to have some more information. So now I can give you a little tip. Generally, hydrogens on an atom that's more electronegative are more likely to come off. And we'll see more examples of this later. But just to start off with, that's what we're going to look for. If there's a hydrogen on a more electronegative atom like nitrogen or oxygen, that's going to come off a lot easier than it would off a carbon. So let's just assume that's going to happen. So we're going to take off this one over here. So now that we know that, what would that conjugate base look like? Pause the video and draw it now. All right, hopefully this is what you got. Just make sure that you have that negative charge in the right spot. And just copy all the carbons the same way they are, because there won't always just be one carbon on the left. There might be 2 or 3 or 90. It doesn't matter. Just copy everything else except for that one thing you're changing. Now with these examples and these couple of tips, you should be able to do the activity for today where you draw the conjugate base of organic acids. You can there'll only be one type of hydrogen like example 3, or there'll be a hydrogen on a more electronegative atom like example 4 for most of the examples. When you get to the very bottom row of that, there'll be some hints on the sheet as well. So that's all we're going to talk about in this video, but we've still got a few more things to mention. So we're going to talk about acid-base reactivity, intro to pKa and what that is, and Lewis acids and bases in the next video. So make sure to stay tuned for that.